So to finish up our notes on ionic compounds, we need to talk about the metals we've been ignoring up till now, the transition metals. So when we first started talking about the periodic table and we started talking about valence electrons, we said don't worry about the transition metals. The reason is because they have varying electrons that are sometimes in that valence shell, because sometimes those electrons from the d orbitals kind of pop up to a p orbital and hang out for a while and then pop back down, which makes it so that they have different charges. Okay, so the first thing I want to do is I want to go over the ones that only have one charge. So they're a lot easier. So flip to the periodic table in the back of your book. I want you to label the transition metals that only have one charge, and because they only have one charge, you must know this charge. So to the top right of each of these metals that I say, put their charge of just that one metal. So zinc has a 2 charge, a +2 charge. So find zinc on your periodic table and put +2 in the top right corner. Put it in pen so you can easily see it every time you look at your periodic table. Cadmium is +2. Cadmium is right below zinc. Silver is +1. Now if you look at the location of these, so if we have silver, Ag, plus, then we have zinc, which is 2+, with cadmium, which is 2+. And then you look a little further up, and you have aluminum. Well, we know the charge of aluminum because of the whole family of aluminum. All of aluminum's family has a +3 charge. So an easy way to remember these elements and their charges is if you start with aluminum, it goes 3, 2, 1. So if you start with aluminum, 3, 2, 1, all the way down to silver. You must always know these. You're never going to be given a hint for it. If something says silver chloride, you should be able to say AgCl, both of which have a 1 charge. So that's pretty simple. You use these charges the same way we always have. The problem is when we start talking about metals that can have more than 1 charges. So if I say copper chloride, you can't just write that formula because you don't know what the charge of copper is. You know chloride's a -1, but copper could be a +2 or a +3. So we need a way to symbolize the fact that that metal has this specific charge this time. What we're going to be using for that is Roman numerals. All of the other transition metals have a special addition to the naming and formula writing system. To identify the charge, they use Roman numerals. So these are called multivalent cations. Multi meaning more than one, valent meaning valence electrons. So you have more than one valence number, and they're cations, they're positive. So these are metals that have more than one possible positive charge. The only new information is highlighted again. Everything else is the same. So like always, we still write the cation, then the anion. The charge of the multivalent cation will be given to you as a Roman numeral in parentheses. The charge of your anion will still be on the periodic table or your polyatomic ion list. To figure out the subscripts, nothing has changed. Use logic, balance out the charges, or use cross and reduce. So for example, if I want to write the formula for the compound iron 3 oxide, then I need to write them out, cation first, iron, so Fe, then anion, oxygen, O, so I'm FeO. Look at their charges. Fe has a 3+, O has a 2-. I can use logic. If this has a 3 charge and this is a 2 charge, I need 2 of these and 3 of these. Or use cross and reduce. My 3 from iron crosses to the bottom of oxygen. My 2 from oxygen crosses to the bottom of iron. So I get Fe2O3. This doesn't reduce. So the only thing that's new here is you weren't able to look at the periodic table to find the charge. You just looked at the Roman numeral. Which, by the way, just really quickly in case we struggle with Roman numerals, this is 1, 2, 3. IV is 4. And V is 5. The one I mostly see people missing is the IV. So now how do we name these? So we write the name of the cation first, like always. But then in parentheses, we need to put the charge with a Roman numeral. So my option A, we have to figure out what this charge is. So option A, to find the charge, we use the known charge of the anion to find the equal charge of the cations that cancel out. So for example, if my subscripts are 1 to 1, then the charges are equal. If it's FeCl, then that Fe must have a 1 charge because the Cl has a 1 charge. If they balance out, 1 to 1. If the subscripts are 1 to 2, the cation has twice the charge of the anion. That's why I needed 2 of the anions. If the subscripts are 2 to 1, the cation has half the charge of the anion. That's why I need 2 of the cation to balance out the 1 of the anion. The other option is to do a reverse cross. So put your arms out and point to the bottom. Cross back up. Okay? So if you put them at the bottom and you cross it back up, that's a way you can find the charges. So if I do a reverse cross, the subscripts go back to the charge position. Check to ensure that the anion has the correct charge. If it does not, multiply both charges until the anion does. What that means is if I had FeO and I did a reverse cross, okay? My reverse cross means I have 1 and 1. This is not the correct charge for oxygen. What that means is this must have been reduced. The correct charge for oxygen is 2, so this must be a 2. If we'd use the logic version, if it's a 1 to 1 ratio, then their charges must be equal. Okay. So for my example here, iron, Fe. To find the charge in the parentheses, we need to either use logic. So if I have Fe2O3, that's the one we're going to look at this time. If I use logic, if I need 2 of these to balance out 3 of these, this must be a 3 charge. So we'd put iron and 3 in a Roman numeral. Or you do the reverse cross. You take the 3 from the bottom of the O, put it back on top of the Fe. Take the 2 from the bottom of the Fe, put it back on top of the O. And that's how you could find the charges. No matter what, you find that it's iron with a 3 in the Roman numeral. And then for the anion, nothing's changed. It's oxide. So let's do some of these. So for the first one, Hg is mercury. Mercury is in the transition metals. It's not one of the 3 we know the charges of, so we have to find the charge. If it's in a transition metal and it's not one of the 3 we have to know the charges of, we immediately put parentheses. We got to figure out what goes here. F is fluoride. Right, remember to change the anion to ide if it's from the periodic table. So you have mercury something fluoride. Well, I needed 2 fluorines to balance out this charge. So each fluorine is a 1 charge, so this must have a 2 charge if you just want to use it logical, or do the reverse cross. If I have a 2 here, then a 2 goes here. And if I have a 1 here, then a 1 goes here. No matter how you do it, mercury has a charge of 2. Mercury 2 fluoride. Number 2, we're looking at naming. My cation is sodium. It is not a transition metal. I already know the charge, so I don't need a Roman numeral. My anion is chlorine from the periodic table, which means it changes to chloride. Number 3, Ca is calcium. It is not on a transition metal, so I don't need a Roman numeral. I look at the next part. This doesn't come straight from the periodic table. This comes from my polyatomic ion list. So let's look at the polyatomic ion list. When you look at your polyatomic ion list, we find a problem. There's an MnO4 that has a 2 minus charge, and there's also an MnO4 that has a 1 minus charge. The 2 minus charge is called manganate. The 1 minus charge is called permanganate. So in this case, we need to figure out which one applies. If we use the reverse cross method we just talked about, if I take this 2 and put it here, and I take this 1 and put it here, then the polyatomic ion here is permanganate. So it's calcium permanganate. Number 4, the cation is Fe. Fe is iron. Iron is a transition metal. We don't know its charge, so immediately put a parentheses. We're going to have to put a Roman numeral there. Then HPO4, I have to look on my polyatomic ion list. Hydrogen phosphate. When you look at your periodic your polyatomic ion list, you find it to be hydrogen phosphate. So when you look at the charge of hydrogen phosphate, it's -2. So if we have a -2 charge for phosphate, and we're looking at how this is balanced out in this formula. So if this whole thing right here has a -2 charge, okay, so we look at this whole thing has a -2 charge, and I have 1 iron is able to balance this whole thing out, this must have a +2 charge. If I need 1 of these and 1 of these, this one has a -2, so this one must be a +2. It's the only way to balance it out. If you wanted to do the reverse cross, then we would do this. You get rid of the positives. If you did a reverse cross, then I would have a 1 from down here comes here, and a 1 from down here comes here, but because hydrogen phosphate has a -2 charge, we'd have to multiply both by 2. It doesn't matter which version you use, whether you use logic or reverse cross, you find out the same answer. The answer comes out to iron 2 hydrogen phosphate. Next we have rubidium as our cation. And then if we look at our polyatomic ion list for ClO4. Now it's not with the chlorates and chlorites because your polyatomic ions are listed in alphabetical order. And this one starts with a P. PER, perchlorate. So I have perchlorate as my anion. I didn't need a Roman numeral because rubidium is one of my alkali metals. It's not a transition metal. We know its charge already. You only need to use a parentheses if I can't just look at the periodic table and automatically know its charge. If you can look at a periodic table and you know its charge because you know its family, or you know that it is silver, zinc, or cadmium, then you have to have a Roman numeral because you have to be able to communicate which transition metal you're talking about. Are you talking about iron 2 or are you talking about iron 3? There is a very important difference there. If you look at number 7, we have zinc and we have oxygen. So my cation is zinc. Now zinc is a transition metal, but it is one of the ones we know its charge. It doesn't have more than one charge, so it does not need a Roman numeral. So it is just zinc, and the anion is oxide. Zinc, oxide. The last one I'll go over is number 22. Sn is 10. Tin is a transition metal. We don't know its charge. It must have a Roman numeral, so let's put our parentheses. We look for HCO3 on our polyatomic ion list, and we find out that it is hydrogen carbonate. Anytime something starts with an H, it's a good bet to go look for the hydrogen part of your polyatomic ion list. So we have hydrogen carbonate. Now you either use logic. If I need 4 of these to balance this out, this must have a positive 4 charge, or you do a reverse cross. If this is a 4, that must have been a 4. If this is a 1, that must have been a 1. This is confirmed by our polyatomic ion list. This does have a 1 charge. Therefore, this 10 does have a 4, which we write IV. If you look at number 14, there's a typo. Notice that there's a 2 here and a 2 here. The way we know it's a typo is, for one thing, these two would reduce if this was actually supposed to be written like this. The other way we know it's a typo is PO3 is phosphite, which has a 3 negative charge, which would have crossed over. So instead of it being Ba2, it should be Ba3. Now that won't affect the name, but that was an incorrect formula. Your homework for the weekend is to complete the bottom of this page and the next page. You need to be able to utilize all of the different rules we've talked about with naming and formula writing. All we're doing on Monday is playing zombies with this naming and formula writing. So with zombies, that always means extra credit for the people who do the best. Also, if my zombie gets to me, meaning everyone knows how to do this, everyone's going to get extra credit. With naming and formula writing, there's a lot of questions because they're faster to go through, so I'm much more at risk of this zombie getting me. So make sure you do study this and look over this over the weekend. The study guide for your test has already been given out to you. It's also posted on Edmodo. If you notice on the bottom of your study guide, it is very emphasized that you need to be able to name and write formulas for ionic compounds for both univalent and multivalent metals, with single element ions as well as polyatomic ions. So if you are struggling with this at all, find a resource. Tutorials, videos, watch the notes of the videos again. YouTube videos are all over the place with help. Make sure you understand these concepts for Monday.